Hello all. Today we are going to demonstrate the object detection task using Edge Impulse as a software-based platform, and the hardware we are using is the Nano BLE Sense. This stuff we are going to execute, which is considered as a labeling method as a one level per data. We are not using the bounding box. Please kindly note this point. Now let's go to the specifications. As of now, we are using the device as a nano BLE sense. So from the target section, make sure you are selecting the device as a nano BLE. Now next task is to collect the data. I have already created few samples. So I am using the two uh, level sample data right now. First is the box class where I'm going to collect the sample of the same nano BLE box, and second is nothing but I'm collecting the data of the hand. So I'm collecting the different images of the hand, and it is trying to recognize those images. Okay, so how to collect the data? First of all, you have to connect the nano BLE sense, and then you have to flash the firmware. So already you have downloaded the Windows Flash firmware. Right click on that and run it as administrator. Okay. So this is a one-time exercise. If you have already uh, deployed the any zip file in your Arduino, then this file you have to do it again. Else the device will be directly going to communicate using the command called as an edge impulse demo. So our firmware establishment has been done. Now we are going to apply the edge impulse demo. Okay, so as of now, if you look, there are multiple COM ports are visible. So I am not aware about where the device is connected. So go to device manager and just verify where the USB to serial device is connected. Right now it's on COM16. So select the COM as a COM16, and these are my projects listed in my hierarchy. So my project is a cam gesture. So select the project, give the name to your nano BLE sense. So this is cam detect. So I'm going to give name as a camtech, and now this device is visible over here with the same name as a camtech. Okay, the device is now visible over here. If you look carefully, so I'm just moving my camera in camera feed towards to the nano BLE sense box, and now I want to capture the image. Sensor we are going to select as a camera, which is of the size of 128 by 96. Label I am giving as a box, and now click on just a sampling. Please keep in mind this is an one level per data, so we are not going to use the bounding box approach over here. So this entire image will be considered as a single level. So just we have captured one image. In similar approach, you have to collect the multiple images. So right now I am using the 100 training images and 35 for the testing images. This is the ratio of 74 by 26. I have set over here. Then go to the creator impulse. By default, size is equal to 96 by 96 of the resolution I'm using here right now. Squash the image to reduce its size to a particular band. Then in the model, you have to select the first option as an image as a pre-processing with the standard model dataset. Don't go for the raw data. And then from the learning block, if you go for the show all the blocks anyway, there are multiple options that are available. So as of now we are using the first option called as a transfer learning from the image. Okay, so select that part. We have right now having two different classes. One is a box, second is hand. Save the impulse and go for the pre-processing. So we have applied the pre-processing using the RGB, and on-device performance we are getting is equal to 11 milliseconds for pre-processing time. its peak RAM is equal to 4 kilobytes. Go for the generate features, apply the generation of the features, and you will find the similar approach. So almost 90% it is distinguishing the two levels. So assuming our model is will work perfectly, switch to the next part for the training of the algorithm, training model of the algorithm. Now, number of epochs we are selecting is equal to 50. Learning rate is 0.005. Training procedure I am using over here over the CPU. I have selected as a GPU. Apply the data augmentation. So if we have right now 100 images, it will try to multiply the images at the some certain extension level with the augmentation in the specific images, which will help for the making the model generic. Okay. From this criteria, from the select a different model, we are going to select the model which will be preferable to run over the nano BLE Sense. So this is a very crucial step. If you remember, our nano BLE Sense is having a RAM compatibility up to 256 kilobytes, and we have to maintain that. So from this model, if I go with the MobileNet V2 with the 0.35 of the learning rate or dropout, so it is going to occupy the RAM around 296 kilobytes, which is going beyond our limit. So make sure whatever the model you are right now selecting should be in the range of your nano BLE size. Okay, so we have selected from this line 96 by 96 of the size of the image. Point 0.1 is dropout, and which is giving me a good resolution for which will be running on the nano BLE size. So MobileNet V1 and V2 are the two different architectures. We are going to prefer the MobileNet V1. So by selecting this model, go to the save and train the model, and the accuracy we received is equal to 90% with the loss of 0.31, which is pretty decent to deploy and to test our existing models. If you are facing some challenges over here, please try to improve the data set and try to add number of more images. Try to avoid the complexity in the background along with the image. Make sure you are collecting the image which is with the proper plain background. Okay, so if it is having clustered background and the particular object, may the accuracy will get dropped down. And apart from that, just try to play with some different options over here. Try to change the learning rate, try to change the number of epochs, augmentation, maybe you can go with that part, and just have a different variations over here, but make sure the accuracy should be up to 90%. Okay, so we are ready to test our model, and we will go for the live classification. So I'm going to click on the live classification option over here. This is our Camtech, which is a model we have selected, the camera connected over here. And now I'm going to connect the image in a runtime, which is live stream, and we will see how much confidence we are getting for this particular object. This is an object called as a box, and I'm going to capture the image in the runtime. Okay, the image has been captured. He's classifying that image, and yes, very good. So you can observe that the result, which is almost with 74% of confidence, he's captured it as a box, which is a true answer. Okay, so this means your model is properly running, and now we want to deploy that model on our nano BLE Sense. Okay, so for deployment purpose, just click on the deployment. From this section, click the Arduino library, which is essential for us, and then here you have to click on the target performance. So this is a very important step. So once you click on the target performance, make sure your target is nano BLE Sense, and we are going to consider the model which is running on my RAM, which is less than 256 of kilobytes. Okay, so there is a comparison between quantized intent and unoptimized 32 point. If we deploy it on unoptimized 32 point, the RAM is around 3300 of kilobytes, and when if we go with the int 8, the RAM is having around 124 kilobyte, whereas the latency, the pre-processing time, it takes around 11 milliseconds. Here is the 658 milliseconds. So roughly around zero point 0.5 or zero point 0.6 milliseconds are required for the intake, whereas for the unoptimized float 32, it is taking around 8300 milliseconds. So a single image may be required to have a time around 8 seconds. Okay, so click on the build. We are going to use the Inti 8 context intent model. So click on the build. Once you click on the build, it will download zip file. Okay, so the zip file has been already I have downloaded over here. So if we go for the downloads, there is a specific zip file Arduino cap. Okay, now next step, once you download the zip file, now we have to use it as a library. So go to the Arduino. From the sketch, go to include library and click on the add zip library. So if you click on add zip library, go to the downloads, select that file, and it will be considered as a library over here, and it will be available in the examples. So go to the section of examples, select the particular example, that is gesture cam gesture interface. Now this is our version V1. So from V1, select the sense camera module, which is running here right now, and you will see all these options. Okay, so now click on this upload button. It will try to upload the data over here. So before that, make sure you have to close this window. So I'm closing this window and I'm going to upload it over here. We will wait for a few minutes. It will take some time to compile. So compilation process is almost finished. It took more than 5 to 10 minutes. So it will take some time. Let's finish the process. So be patient for this particular compilation time once you are going to deploy it on the Nano BLE Sense. Now it has been started to upload in the Nano BLE Sense. Took some time. There is 107 pages of size. Flashing has been done. Now go to the section of tools and select the port. Port is COM60 for my case, and then click on the serial monitor. Okay, so it has started to take the photo, and if you look carefully now, there is no any overflow or frame rate error is there. So tensor arena overflow is not occurring right now because we have mapped our model to run to fit perfectly the size of RAM in the particular size specifications. So in a runtime, I do have right now hardware with me, that is Nano BLE Sense, and I am switching that hardware towards to the box. Just I have switched it towards to the box. It's capturing the photo. It is capturing the photo right now. Yes, and now you can observe the prediction is coming around 0.78% for the box, which is pretty decent. So it takes some time to capture and to process the data. Yes, 93%. So this is how the object detection project is going to execute over here. So I will just add some part over here, which will look like how the hardware is going to process over here at onwards. So thank you so much, and you may try this execution at your own end.